Hi, welcome to the notes for 3-7. In today's lesson, we are going to continue multiplying and dividing with radical expressions. A little warm-up for you. It says simplify the following expression. We have the square root of 3x times the quantity of a square root of 6x plus a square root of 2x to the third. Let's go ahead and get started. So with this, as you look inside the grouping symbols here, right, those are not like terms, so we can't add those together. So it looks like we're going to be distributing the square root of 3x through. Let's go ahead and do that here. So when we have it, we'll say this is the square root of 3x times the square root of 6x, and then we've got plus the square root of 3x times the square root of 2x to the third. And now it's just like what we did in the previous lessons there. We're just going to multiply the radicals together. So when we do that, right, I'm going to take it and break them into compatible parts. I've got my 3 times my 6 here, but I'm going to do, instead of 6, I'm going to say 3 times 3 times 2. That way I can see my perfect square factor. And then we're going to multiply that times the square root of x times x, or x squared. And then we're adding, and on the same concept here, we're going to break our numerals and put them together. So it'll be 3 times 2 times the square root of x times x to the third would give us x to the fourth. So we see here that we would have had a 3 squared there, a 9, and we know the square root of 9 is 3. So we have 3 times the square root of 2 times an x plus, on the other side, we have a square root of 6 times, and then our square root of x to the fourth is x squared. And now we just need to combine between each of those. So when we put these two together, it's 3x radical 2 plus, on this side, x squared radical 6. And those are not like terms, so therefore we are finished with that one. All right, so today we're going to have a lot that deal with quantities, or multiplying binomials times binomials. So this kind of combines a lot of what you did earlier in previous chapters with the radical expressions that we've been working with in this chapter. So example 1, multiplying binomials. It says simplify each expression by multiplying. When we look at the first two, we have 4 radical 2 plus 7 times 4 radical 2 minus 7. So you should be able to recognize already that this is a difference of squares, but even if you don't, let's take a peek at what happens. So when we start out here, right, I'm going to just FOIL this. I'm going to do my 4 radical 2 times 4 radical 2, and then I'm going to do that 4 radical 2 times negative 7. So let's just start out with that here. If I do 4 radical 2 times 4 radical 2, right, we could also write that as 4 radical 2 squared. But let's see here, then I'd have a plus 4 radical 2 times a negative 7. And now I'm going to go into a positive 7 times 4 radical 2. And then I've got a positive 7 times a negative 7. Right, I'm just trying to color code it so you can keep track of the, everything that's going on there. As we look to simplify these, right, when we do this first part, 4 times 4 is 16. And then we have a radical 2 times a radical 2, which is going to be radical 4, 2. So that's going to get us 32. Then we've got a positive 4 radical 2 times a negative 7, which should give us a negative 28 radical 2. Then we have a positive radical 7 times a positive 4 radical 2, which is going to give us the opposite of that, which is positive 28 radical 2. And then at the end here, we've got 7 times negative 7 is negative 49. Okay, so just like with a regular difference of squares, right, those middle two terms are going to cancel out. So we're just looking at 32 minus 49, which should give us a negative 17. That is our answer. Okay, so if you wanted to go ahead and apply, your shortcuts there, right, we know that a plus b times a minus b is equal to a squared minus b squared. You can apply that. Okay, we'll apply it again here in a little bit. I'm not going to go back and redo the same problem. Now this next one, we are going to be taking our quantity here and we're squaring it. So remember, you're not distributing that exponent through. This is the same thing as saying 3 radical 5 plus 4 times another 3 radical 5 plus 4. So since we're squaring the binomial, we're going to get a perfect square trinomial afterward. Now, if you don't remember that, or you can't remember what a perfect square trinomial is, you're just going to do the same thing then. Let's just go ahead here and we'll just FOIL this out. Okay, so you're going to do 3 radical 5 times that second 3 radical 5. And then you're going to say plus 3 radical 5 times a 4. And then you've got that 4 times 3 radical 5. Oh, I'm writing that wrong. Let me fix that. You'd had what was 3 radical 5, right? So times 3 radical 5. And then you'd have the 4 from the left side. I'm struggling with writing anything. There you go, plus 4 times the 4 from the right side, right? And just think about this though, right? Another way you could write all this instead of writing all that down, you could just say this was 3 radical 5 squared. And then in the middle, right, you have a 3 radical 5 times 4 and another 3 radical 5 times 4. Isn't that the same thing as saying 2 times our 3 radical 5 times a 4? Okay, because remember, it's a perfect square trinomial. And then at the end there, you could also say that this was like times that last term squared. So if you want to use the shortcut there, instead of writing all that out, you can do that, right? 3 radical 5 squared is going to be 9 times 5, or 45. That's the same thing you get when you use this up here. Okay, and then 3 times radical 5 times 4 is 12 radical 5. And when I multiply that times 2, I'm going to have plus 24 radical 5. That's the same thing you'll get if you take this and you simplify it and then add it to this. And at the end, we'd have plus 16. And now we can combine our like terms. We're going to have 45 plus 16 should be 61 plus 24 radical 5. And that is our answer on that one. Third one, we don't have any specific patterns to our binomials. We're just taking it and FOILing it out. So we're going to do the first part, 3 radical 5 times 2. Then we have plus 3 radical 5 times a radical 3. Then we've got a negative 2 radical 3 times a 2. And then we've got a negative 2 radical 3 times a positive radical 3. And then we'll just simplify each. So this one here is going to be 6 radical 5. This one here is going to be plus 3 radical 15. Right here, we're going to have minus 4 radical 3. And then at the very end, 2 times a radical 9 or a 3 would be minus 6. And you'll notice here that there aren't any like terms, so we will just take all of those and call that our answer. All right, if there's questions, please make sure you reach out. Let's keep moving. So example 2, binomials divided by monomials. So the directions here state to simplify and then to rationalize the denominators. Well, a couple ways we can look at this one. Okay, when I'm looking at A, I want you to think about this first, okay? Because I want you to think about before you do it to help cut down on your work if you can. Okay, so you don't have to write this down just yet, but remember, we can always take this. This is being divided by radical 7, and this is being divided by radical 7. So we can write it that way if we need to. We could say 2 divided by radical 7 plus radical 3 divided by radical 7. Now here's the thing, right? That didn't really help us at all. It may have added to the amount of work that we have to do. So rather than doing that on this one, okay, we could take it and simplify each of those and add those together, but let's just start up at the beginning. Let's just multiply the bottom by radical 7, right? This is going to rationalize our denominator, and then let's just do the top by radical 7. Okay, so we didn't really need this over here on this one. So let's see what we get. We're going to treat this like it's a quantity. You're going to distribute this through. So we have 2 times the square root of 7 plus the square root of 7 times the square root of 3, which is going to be the square root of 21. And that should be over square root of 7 times the square root of 7 is going to be the square root of 49, which we know is going to be 7. And when we look at this expression here, we cannot simplify this anymore. Therefore, that is our answer. Okay, so why did I go into that whole, tidbit at the beginning here? We're looking at all of this. Well, when we do this next problem, let's see what happens. I could say that this one, when I recognize 3 does go into 18, I could write this as the square root of 18 over the square root of 3 minus 2 times the square root of 75 over the square root of 3. Now, in this case, it actually may help us because remember, we can treat this as the square root of 18 thirds, which is really going to be the square root of 6 if we reduce it. And then here, this is like saying 2 times the square root of 75 divided by 3, which we know is 25. So we have minus 2 times the square root of 25. And the square root of 25 we know is going to be 5. So really, this goes a little bit further. And we get our final answer of the square root of 6 minus 10. That is the answer for this one. Now you could still take this one and do this one the same way we would have done, on the left side with that one, right? Where we took it when we multiplied the top and the bottom by the square root of 3. Okay, so we could take that and we could distribute it through here, but when you start looking at these numbers, they're not very pretty numbers to deal with. So if you can simplify it down first, why not do that? Let's move on to the next one. All right, it says, what is a conjugate? And then we've got a little definition here. It says conjugate, switching only the middle sign in a pair of binomials to get a difference of squares. We've talked about difference of squares. You learned it in Algebra 1. We've already taken time this year to review it. So you should know what it is. And remember, that's this. If I have a plus b times a minus b, it should give me a perfect square minus another perfect square, or this, a squared minus b squared. So technically this part here is like our difference of squares on the right side there. But it comes from multiplying these binomials where the only difference between them is that sign in the middle. So if I wanted to take the square root of 2 minus 3 and I ask you, what is the conjugate of the square root of 2 minus 3, you would tell me that the conjugate is, actually I'm putting a little question mark there. All right. So our conjugate would be the square root of 2 plus 3. So notice that thing that's different there is that middle sign. So what is the conjugate? The conjugate is the square root of 2 plus 3 on that one. All right, so now that we can identify what a conjugate is, okay, we have to use conjugates to help us rationalize denominators. We have binomials in the denominators. Okay, so this is where we've got a binomial in the denominator. And so if I have 4 over 2 minus radical 3, I need to multiply the top and the bottom by the conjugate. I'm going to write that on here. Multiply both top and bottom by the conjugate of the bottom. Actually, I'll say of denominator. That's probably the better word. Okay, so our conjugate for 2 minus radical 3, we already said was 2 plus radical 3. So I'm going to multiply that down here. But if I do it to the bottom, I want to keep it proportional. We're going to do it to the top as well. So we're looking at 2 minus radical 3 times 2 plus radical 3. And then we've got 4 times the 2 plus radical 3. So on the top, we can go ahead and just distribute this 4 through. We now have 8 plus 4 radical 3. In the denominator, what we're going to do is, you can take it and you can FOIL it out. But remember, a minus b times a plus b equals a squared minus b squared. So if you think about A is just 2, and B is equal to the square root of 3. So let's just do it this way. Let's just say here we're going to do A squared is 2 minus the square root of 3 squared. Okay, and that makes it a little bit easier than taking it and FOILing it out. Okay, if you FOIL it out, you're going to get the same thing, but we don't need to cancel out the middle terms and all that stuff here because we know they're going to cancel out. So this will give us an, oh, I wrote 8 in there. I meant to write 2 squared. Sorry about that. Let's fix that. That should be 2 squared minus radical 3 squared, which should give us 4 minus 3, or 1, right? So 8 plus 4 radical 3 over 1, which should just be 8 plus 4 radical 3 in the end. All right, let's try with the next one. Letter B says 4 plus radical 2 over 5 minus radical 2. So we need to rationalize our denominator because we have this radical down here, right? So we need to take this and multiply it times the conjugate of the denominator. So we would say this would be 5 plus the square root of 2. And if we do that on the bottom, we also have to do it on the top. And what we're looking to do now then, right, is we're still going to multiply this one, though you're going to have to FOIL out the top. So when we do that, let's see, we have a 4 times a 5, which would be a 20. Right, so we did this times that. We do a 4 times our radical 2, so plus 4 radical 2. And then we got radical 2 times 5, which would be 5 radical 2. And then radical 2 times radical 2 would be radical 4, 2. So that's our numerator. In the denominator, we know it's a difference of squares. So we're going to say 5 squared minus the square root of 2 squared. And we'll just simplify each of those. The top, we're going to get 22 plus 9 radical 2. On the bottom, we're going to have 25 minus 2. So our final answer would be 22 plus 9 radical 2 over 23. And that is our answer. Now we have that same thing, but with a rational denominator. Now, if you want to check it, let's try this here, right? So let's clear out our calculator. If we do the original function at the top, right, however you want to put in your fractions there, I'm going to say this is 4 plus the square root of 2. Right, on the bottom, we're going to have 5 minus the square root of 2. All right, so let's see what kind of number it gives us there. All right, so about 1.5099. And now let's do our new fraction. Okay, so let's just type it in there. We've got 22 plus 9 times the square root of 2. And then on the bottom, we have 23. And we see after we do that, we get the exact same answer. So you know that it is correct. Please get in the habit of wanting to check your answers. It helps. All right, I got a couple more. The next one says, show by substitution that the given expressions are roots of the given equation. All right, so what does that mean? Well, that means that we have a parabola here, and if we took it here and we graphed that parabola, right, let's just do this so we can see it. Let me move my calculator over here. We've got 2x squared minus 4x. Come on, calculator, work with me here. Minus 4x plus 1. Right, if we graph that function, where is it at? There we go. There is our parabola. And you'll see here that it's got 2x intercepts. It's got one at about 1.707 and at 0.292, right? Well, it just so happens that those values are listed right here on your paper, right? That's these two values right here. They're just in our radical form instead of our decimal form. So what we want to know is how can we show that those are actually roots or not? Okay, so what we can do is, just like you do normally, you can take one of these root values, right? This is like saying, x equals 1 plus radical 2 over 2, and x equals 1 minus radical 2 over 2. Anytime we get our root values, we should be able to take them and plug them in for x, and it should make it a true statement. So let's do that. We'll just take one of them. Let's choose the 1 plus radical 2 over 2. We're going to plug this one in. So we've got 2 times the quantity of 1 plus the square root of 2 over 2 squared minus 4 times 1 plus the square root of 2 over 2, and then plus 1. This should all equal 0. Okay, so I'm going to get this one out of the way for the moment. All right, remember, you're not distributing the exponent through. This is like saying 2 times 1 plus the square root of 2 over 2 times 1 plus the square root of 2 over 2. So probably, you can look at it from a couple perspectives here. You can either FOIL that out and make it a perfect square trinomial, which might be the easier way, even though it looks like there's fractions and things in it. Or you could distribute your 2 through one of them, okay, not through both. I'm going to go ahead and do my perfect square trinomial. I know that this is going to end up being a 1 squared, right, a squared, plus 2 times ab, so plus 2 times 1 times our radical 2 over 2, and then plus our b term squared, so radical 2 over 2 squared, right? Let me just throw this up above so remember what that means, right? If I have a binomial and I'm squaring it, if it's a perfect square trinomial, it's going to be a squared plus 2ab plus b squared. And I just used this formula to write this expression down here. So when we simplify that, we've got 1 plus, if I do 2 times 1 is 2, and then I do 2 times radical 2 over 2, I should just have a radical 2. And then at the end here, this should be plus a radical 2 over 2 squared. So that would be a 2 over 4, right? Or 1/2 if you wanted to simplify it. So we got basically, you could say this as 1.5 plus the square root of 2. Okay, that's from multiplying those together. But when we bring down our 2 and we distribute that 2 through, we're going to have 3 plus 2 times the square root of 2. That's just this part of it. Now, the next part of it, we need to distribute this negative 4 through. So when we do that, negative 4 times 1 is negative 4. And then negative 4 times radical 2 over 2 would be a negative 2 radical 2. And then we'll bring down our 1. And let's see what we got here. So I have a positive 2 radical 2 and a negative 2 radical 2. When I add those together, they're going to cancel out. And then I've got 3 minus 4 is negative 1. And then when I add that other 1, I do get 0. So 0 equals 0. So I know that this is a solution up here, right? Our 1 plus radical 2 over 2 is a solution. We have verified that it is a solution. And if that one is, its conjugate there would also be here because, when we plug it in there, we have the plus or the minus. So that should also work for us. So yes, that one works. All right, let's go to the last example here. It says use the Pythagorean theorem to find the missing value of x. So remember Pythagorean theorem, when we have a right triangle, we have a squared plus b squared should equal c squared. Let's just take our expressions and plug them in, right? So a, we have 4 plus radical 2 squared plus our b, which is 4 minus radical 2 squared, and that should equal our c squared, which should be x squared. All right, so let's take this and go through it, right? So if I'm going to square this binomial, it's a perfect square trinomial that should result. So we should have a 4 squared plus 2 times 4 times radical 2, and then plus the radical 2 squared. And then our middle terms, same thing should happen, right? We should have plus 4 squared. Then we should have a minus our 2 times 4 times radical 2. And then we should have plus a radical 2 squared. Remember, at the end, when we do negative radical 2 times negative radical 2, you should get a positive radical 2 squared. Okay, if you need to take it and FOIL it out, that's fine. Okay, this is why it paid attention to, or it would have paid off to pay attention when we went over this and reviewed it in chapter 1. So let's just simplify. We've got 16 plus 8 radical 2 plus 2 plus another 16, this time minus 8 radical 2 plus another 2, and we're saying that should equal x squared. Well, this is super convenient and nice, right? Because 8 radical 2, a negative 8 radical 2, those two will cancel. Then we're going to add together 16. Whoops, wrong tool. Oh, great. Let's find it. Where'd it go? There it is. Bring it back out. So this was a 16, plus another 16 is 32, plus a 2 is 34, plus a 2 is 36. So we've got 36 equals x squared. We'll take the square root of each side. And remember, it's a distance, right? So we don't need to worry about the absolute value and the negative. We should get just x equals 6 on this one. Therefore, the length of x is 6. All right, so that's how we can use our skills with multiplying and dividing radicals to be able to solve a problem like that. And that's it for the notes. So if you have questions, you need to make sure you reach out and ask. All right, that's it. Thanks for watching.